Raducanu was actually born in Toronto. So I was calling it the All-Canadian final at the US Open, but amazing to see two strong teenage women in the final of a tennis match. That was so exciting. Thanks too for hanging in here to the end. It's a long session, and so I appreciate everyone's attention. As Paul said, I'm a Director of Enterprise Science and Innovation Partnerships here at Thermo Fisher Scientific. I report into our Chief Science Office, and we really work with customers to work on kind of long-term collaborations and kind of look where your needs are going in the next 3 to 5 years. And so what are the features in terms of science as well as technology that are really going to drive the future of the industry? And my particular focus is something we call lab transformation. I've been in the industry for 25 years, lived in the UK, obviously born in the UK, lived in Sweden, in California, and now here in Toronto. So before we really get into the talk, I think it's great to start with a bit of a definition. So what is a digitally native lab? What do we mean by a digitally native lab? And this is a lab that contains digitized systems. So it's a paperless lab as much as possible. It contains instruments that are connected, so Internet of Things. It contains informatics solutions, robotics, automation, immersive technologies, and data science. So that's what it is, but just as important is why. Why do we want digitally native labs? Really, it's all about delivering increased quality of results, reducing the time to those results, whilst increasing productivity and reducing costs. You heard Paul talk about one of the big motivations for digital commerce is it reduces cost, and the same is true in kind of lab of the future initiatives. So interestingly, I spend most of my days working with our larger customers, so some of the leading biopharma customers around the world. And their challenge is really legacy systems. So you can see some data here from a recent study done at the end of last year around digital transformation. And you can see a lot of the challenges that larger companies are facing is really all about their existing systems, decisions they've taken in the past, current infrastructure that's presenting them from taking advantage of some of these digital technologies and some of these transformative ways of working. Alongside those technology challenges, there's also the people challenges, which is how do they reskill or acquire or attract and retain the people that are happy working in a digital environment and really are digitally native. A few headlines here, obviously just reflecting the fact that the pandemic has also accelerated this transformation, both in labs as well as across businesses as a whole. So this is how we view digital transformation or lab transformation, and you'll often hear it called the Lab 4.0 journey to line up with Pharma 4.0. And the first part of the journey really is the connected lab. So how to connect the people, the equipment, the consumables, the systems, and the data. So you really have kind of a clear starting point and high quality data. The second step is then, once you've got that data in place and that infrastructure in place, to start thinking about automation. So once your capabilities are connected, then and somewhat stable, automation can be used to accelerate science and drive productivity. And that leads us to the third and final step, advanced analytics. So once you've connected your data and optimized your workflows, it allows you to look at the data in new and exciting ways, apply it to critical business challenges, and really most importantly, and get the insights and understanding that you need in ways that weren't possible before. Cool. So before I start diving into the connected lab, I have a poll to make sure people are still awake. Jenny, can you fire off the poll? So the question is, how familiar are you with FAIR data principles? This is great. I'm hopefully sharing the results here. It tells me that I'm talking to the right kind of audience. So there's not a lot of familiarity with FAIR data principles on the call. And that's great because that's what we're going to talk about next. So underlying digital transformation is the concept of fair data, which is key in today's laboratory environment. So fair data, so FAIR stands for findable, accessible, interoperable, and reusable. So it's really about treating data as a very valuable resource. And that can be everything from the data that again, Paul touched on in terms of digitally, what are we buying, how are we buying it, where's it stored? But there's also scientific data. And it's really, if we get our data to apply to these FAIR principles, it becomes a lot more valuable to us. There's a famous AI scientist here in the US called Andrew Ng, and he talks about good data beats good models. And that is, without good data, then any AI and any AI and any machine learning you do is really not going to deliver the value that you expect. So it's really important that companies think about making sure their data is fair as much as possible from the beginning. And again, many companies, you're not alone here, many companies are finding, as they start to move towards lab transformation, they're finding that their data is not fair. And you can see here in the recent survey Accenture did, that was up to about 88% of people overall. It's also good to remember that there's different types of data. So scientists, often the first data they think of is the experimental data. So this is your raw instrument data, metadata related to those experiments, as well as data that's been processed. This is the data that enables those advanced analytics, and the collaboration is really driving the science and the discovery forward. But then there's also operational data. This is data about the instrumentation you're using, the workflows, the processes. And this is really what drives some of those business insights in terms of how are my equipments being used, when are they being used? If I walk up to an instrument, do I know it's been calibrated and available to use? Is it booked by somebody else in the lab? So really, when we think about data, it's important to think about these two different types of data and how they're both really important as we're thinking about digitalizing our lab. So how can this data drive productivity? So if we start on the left here, instruments and equipment. So having data about our instruments, having them IoT ready, having remote monitoring really drives our productivity and gives access to information about the status of those instruments and access to that data across the company. It also ties into that centralized asset management. Is the equipment fleet I have, is it being used efficiently? Perhaps I have some instruments that are used 100% of the time, and I could look at acquiring more. Maybe there's some instruments in other labs that are not being used as much, and we could allocate those instrument resources somewhere else. Consumables, another nice picture here are the supply centers. So again, simplify ordering and managing costs, making sure that the people have access to the consumables they need when they need them in real time. Here at the central slide, most important is the people. And there's several aspects to this, and often the people get forgotten in lab transformation, but they really are the key to success. It's both enabling collaboration, but also making sure that the working environment is rewarding and stimulating to those people. So we want the scientists to be focusing on the science, not spending time tracking down data, having to transform data from an Excel and put it into a database, not having to track down consumables, not having to see if an instrument has been calibrated and available for use. Scientific workflows comes next. So knowing what tasks are available, what tasks come next in a workflow. So orchestrating workflow to connect processes definitely drives efficiency and productivity. And then lastly, again, as we've touched on before, the data is the most important. So having this connectivity means you get all the data you need, good quality data. And if we apply those FAIR data principles and data standards, it really is going to drive the quality of the insights that we can draw from that data. And of course, it's important not to build data silos. So the value of the data is not just in one lab or one facility, but it's having that data be accessible as we go through that molecule to medicine process. So we need to share data within research, but then how do we pass that data on through process development into the clinical phase, speeding up the clinical phase and making data available, as well as potentially passing data back to the research phase so the organization can learn and optimize its processes as it goes through this cycle multiple times. Again, there's another tech transfer here from the clinical phase to the manufacturing phase, making sure the data is available to go through the process. And as Chet talked about as well, there's also the data transfer to potential outsourced partners. So again, having those data standards and that fair data just introduces efficiency throughout the whole workflow. And the key takeaway here is really that having that secure and repeatable data transfer is what enables you to accelerate your time to market. So just touching briefly on what some of the capabilities we have here in Thermo Fisher Scientific. So we have capabilities in the electronic notebook space. We have capabilities in the LIMS space, so connecting the R&D ecosystem with Platform for Science. And we also have Watson LIMS used in the majority of the top 20 biopharma laboratories. And then we have Sample Manager, which is used very heavily in the manufacturing space. And then we also have scientific data management solutions. So where you assign your data with the process results, and again, using open standards here with access to many, many different formats. So you're not locked into one data type and can cope with that vast array of different types of data that's available and you'll need in your organization. And then a quick recent use case of how bringing in this connected laboratory can help is we're lucky at Thermo Fisher in that we have one of the leading CDMO organizations, the Patheon brand, with over 55 sites globally around the world, and has been part of delivering 50 of the top 100 selling medicines over the past decade. And we did a project with them to really look at bringing digitalization to their QA/QC. This was using our Sample Manager product together with connected instruments. And you can see here from this quote, this was really moving a lab that you still used a fair amount of paper and a fair amount of those manual processes, and really moving them into the paperless era. And that's driving significant advantages in both efficiency, productivity, as well as compliance. So the second step on the Lab 4.0 journey is robotics and automation. So once you've got your basic data infrastructure in place, and you can then move on to look at automating some of those workflows and some of those processes. And these are some of the challenges that automation can solve in a laboratory environment. So the first one, and the one that's most commonly identified with automation, is maximizing throughput. So how do we increase the use of those equipment, and how do we get the most samples processed in the shortest amount of time possible? But an advantage that people often don't think about is the ability to enhance reproducible results. So automation, I think it was Paul mentioned earlier that people can have bad days, and you get increased reproducibility, increased consistency by using automation, which is really important for maintaining sample processing uniformity. So every sample is treated the same, so increased data quality there. Reducing errors. People can get distracted, pick up their phones. So automation generally doesn't make a mistake. And if it does, it has a record of that mistake. Automation also enables us to scale. Automation solutions today are much more modular in nature and can easily be expanded, both as the current workflow increases in capacity, as well as versatility in terms of adding new workflows. And lastly, automation decreases the hands-on time required by FTEs, freeing time up for them to focus on the science and the research. Again, just briefly touching on some of the automation solutions we have here at Thermo Fisher Scientific. We have solutions ranging all the way here from the left to kind of small benchtop, what we would call instrument loading solutions, through to benchtop automation, perhaps automating a simple workflow, all the way through to the right-hand side there of kind of very large systems that are automating multiple workflows and truly running kind of in a 24/7 environment. And hopefully this video works. Yes. So here's just a video of one of those from the right-hand side of the slide, like a large-scale automation. This is a system that's definitely at the high end of what we do in terms of complexity with 7 robotic arms, 66 instruments integrated, and 3 conveyor systems connecting 3 separate systems together. And this is doing an NGS workflow. What's interesting about this system is it's run 6 days a week, 24 hours a day, and then they use the 7th day for a full reloading of the system, preventive maintenance, before starting it all off again next week, for the next week. So the last step on the journey is really about making the labs intelligent. So we have the basic data infrastructure, we have fair data, we have good quality data. We've automated our stable process with robotics and automation. And through that, we're really generating the data we need to drive intelligence, so insights in our lab. And so by enabling digitalization, we enable advanced data analytics. Here's just an example using R Shiny, but different companies have different analytical tools, and they can use those to apply to the data. So again, it's having that high quality data that enables you to drive the insights. And high quality data enables AI, machine learning, and goal-based science. So there's been obviously a dramatic increase in the use of these technologies in assessing our data. And really nothing is possible without high quality data. And here's a case study kind of really showing that intelligent lab. This is the result of a collaboration we have with Carnegie Mellon University on the East Coast in the US. And we put in place an automation system, which is interesting because it supports their Masters of Science in automated science. So Carnegie Mellon University actually has a program teaching the researchers of the future how to integrate some of these Lab 4.0 principles and teach them that as a master program. So it uses that connected instrumentation we talked about, the data structure, robotics, and AI to scientific research. And a double benefit of this is this facility enabled the university to continue to offer this program even during the pandemic, because they switched to remote operation of the system. So some of the very principles that our customers have been asking us around is, how do we enable automation to continue business continuity at a time when maybe we can't get people in the lab? And you can see here the goal really is the self-driving instruments to drive that, sometimes called closed loop science. So the robotics generates the data, the machine learning interprets the data, and then artificial intelligence tells you which experiments to run next. And we go through this cycle of learning. So this is what I would call automated science or closed loop science. So in summary, a digitally native lab delivers long-term benefits. So some of the benefits are eliminating the manual lab work, increased throughput, more reproducible, less errors. It enables you to manage your samples throughout their life science by having those LIMS systems, that connected data. Connected lab workflow, so you can move samples from one workflow to the next. Be aware of the consumables needed, so you're never short of consumables. You have a digital lab environment, and then you have that accessible data for analytics, that fair data. And ultimately, this comes down to giving you increased quality of results, reduced time to results, those improved productivity and reduced costs that we were looking for. And it's really foundational for any advanced analytics and AI ambitions. Let's click through those. And of course, as with all the things we've talked about today, Thermo Fisher is here to help. So whether it's through connecting your laboratories, through LIMS and ELN systems, whether it's automating through robotics and advanced instrumentation, or whether it's through some of our innovative data science capabilities. And I think we have maybe a minute or two for any questions.
Thank you, Ian. Really, really, really fascinating. And I'm personally really interested in this automation one. I'll crack on with a quick one, if you don't mind. Obviously, is to, it looks appealing and you make the case of why that's important. But what would you say are the most critical factors to consider early when you're building a lab on the future?
I think it's obviously a balance as a small company or a company that's growing. There's lots of priorities, there's lots of things to focus on. And it can sometimes be hard to put the energy into some of those future-looking things like building that data foundation. It's people get started with Excel and small databases, and they build together a solution that works for now, because that's what a small company does. It's what do we need now? So I'd say it's really at least starting to map where are we going, what will this data be used for? Like we saw those FAIR data principles, and again they're fairly straightforward. It's findable. Can I find the data pool? Is it accessible? Is it interoperable? Can I use it between different groups? And those it's asking yourself those questions, and it means you don't go down the route that causes you problems later. And as I talked about earlier in the talk, some companies find themselves in now transformation is hard because of decisions we made earlier on. So I'd say that's really what to think about at the beginning, is what is my data foundation? Because that data is going to drive so much of a company in the future.
Yeah, and I think this data foundation, as you said, it's not just if you go the automated route, is for any type of organization. That's where they should start. But would you say you would need sort of a lead to go to this lab of the future direction, or do you need to consider training for staff, or is it critical, I would say?
Yeah, great question. I once worked, when I worked in Sweden, I was part of a high throughput screening organization that AstraZeneca created, well, it was Astra at the time. And I remember one of our first hires was a data scientist. And I think that was really important because they built that capability from the ground up with us, the scientists, and with us, the business leaders. Having that data scientist from the beginning, I'd say, was a key part of our success as an organization. Otherwise, we'd have messed it up. As scientists would have been still using Excel, and he was the one that made us follow some of those data foundations from the beginning. And as I talked about, often people are forgotten in this lab transformation. We need to consider how they're going to work in the labs and how they're going to operate. So I think that's a key part to any digital lab, is the people.
Bringing the data scientist to life sciences. It's a good message. Yeah. I'll just close up with a quick one, because obviously the automation system that you showed was really impressive. And I like the idea that robots also need a day off in the week. That's a good thing. But anyway, how long does it take to design and deliver something of that scale, what you showed? Because it's great to see, but maybe to get that back in the context of an organization, well, how long does that take, and maybe costs?
Yeah, so a system like that is definitely, you're looking at perhaps 6 to 9 months from kind of concept to delivery. That company, I remember, did have a very aggressive timeline, so it was closer to the 6 months. But what's nice about automation nowadays is you can start small. And again, it's a bit like the data we have as a company, kind of small benchtop solutions. So it's getting people familiar with using those kind of solutions early on. And then you start to think about, how do I build my assays? How do I build my workflows for automation? Maybe using simple modular benchtops. And then when you're ready for making a move to a more dedicated system, you have that experience again with the people who know how to think in an automated way. And so I definitely wouldn't start with a system of that size. So I think it's great that you build up to it. So, and those benchtop systems, you can get them in a few weeks and be up and running. And obviously the barrier to entry is a lot lower, but the principles are the same. So they set you off on a good path to a 4.0 lab.
Yeah, it's gradual implementation.
Yeah.
It sounds good. Okay. That's it on my end. So giving you the floor.
Thanks, everyone. I think it's back to Ashley for the